so let's talk about objects. So let's kind of talk about it at the high level here. That is not us. Okay, so we're past the easy merge sort. All right, so if we think back to first couple weeks of class when we were talking about the two kinds of programming languages, three kind of programming language actually. We said functional, procedural, and object-oriented. And then we kind of said don't worry about functional for right now. So really in our world, we're kind of comparing procedural versus object-oriented. Now, most modern languages are object-oriented languages. But most beginning programmers, when they first start using a language, are using it in a procedural manner. So we've been using all our languages all procedurally at this point. And if you remember back to the example, what example did I give for the difference between procedural languages and object-oriented languages?
Phone, the wires, not the wires.
Yeah, so the pile of wires over here, you walk in, I say, hey, I promise you that's a phone. And you don't believe me, but you work through it and you say, oh yeah, it looks like a phone that you exploded all the wires out of it, but it's a phone. Okay, where when we deal with an object-oriented language, we stuff all those wires back into a little box and say, oh, that's a phone. And that's what we believe looks like a phone, even though we believe all those wires are in there. All right, so we want to start conceptualizing our programs in terms of objects that we use, just like in real life. Okay, we go back to also week 1 or 2, whenever we said it, that one of the jobs of a programming language is to allow human beings to solve problems in a way similar to how we solve problems in real life. All right, so when you need to use the phone, you don't go and pull out the pile of wires from your backpack or from your pocket, right? You pull out the phone object, and then you interface with this object using the public interfaces of it. You know there's a whole bunch of details in here that you never touch, right? There's transistors and stuff like that you never have to physically interface with. You don't have to physically interface with the battery. You get a little meter on the screen that lets you know how bad things are, okay? But you never have to actually work with it. So all these details are inside of this little box, but only the ones that you actually have to manipulate, work with, are publicly exposed to you. Those would be the public interfaces. That make sense? Okay, so an object is all the detail inside of a box with only the public interfaces shooting out so that you can use that object. All right, and that way it's also more convenient to pass around because you might perceive that we're going to be passing objects into functions and things like that. All right, you'd much rather hand somebody your phone than hand them a pile of wires. Okay, that's kind of like, kind of like me untangling the VR thing after I've been playing for 3 hours and spinning around a bunch and the cable starts looping back on itself. It's always bad when you're in the middle of a fight and you start strangling yourself. And you have to decide which is better, your survival in real life or your survival in game. Unfortunately, I usually pick in game. I figure I could go for at least 5 minutes, probably, before permanent damage has been done. My wife finds me. I'm basically hung myself via the cable. But with my weight, I've pulled down the drop ceiling where I have it all mounted. So, this is the aftermath. You got just an unconscious guy with all this drop ceiling tile laying on top of him. It's like, what happened?
That paused the game.
It kind of reminds me I just took up fishing 2 years ago. I never really, when I was a kid, I went fishing for bluegill or something a couple times, but I decided, I'm going to take up fishing. And when I take up something new, I'm kind of an all-in type of personality. So I decided the best way to learn how to fish was to join a bass fishing club and fish in tournaments. So the first time I ever caught a bass was in a fishing tournament. Well, so the night before, I'm like getting all my stuff ready because I joined this club. And, I didn't know what I'm doing. So I'm like putting the line on the reel and stuff. I'm out there for hours trying to get this stuff because I have big hands. And so my wife comes out and I had lost a shoe. In the process of because the thing got tangled on my shoe and it kind of flipped it. So my wife's like, you shouldn't go to this. If you can't get your fishing stuff ready without losing a shoe, you're not ready. Right? How do you lose a shoe?
Although I'm guessing
Well, that was the funny thing. So the guy who was like the president of the bass fishing club, he took me out as the new guy on his boat. And I beat him. He caught no fish that day. I caught like 2 5-pound bass. Yeah, it was awesome. I didn't even know what I was doing. I could, he's like doing all these like special techniques thing. I'm just throwing like the spinner thing out and just reeling it in. All these guys had like 6, 8 poles. I had like 1. I think that's the definition of beginner's luck. All right. So in any case, when in real life, we think about things in terms of objects, right? That's our natural way of thinking, even though, we don't drop it down to that level. So this is, again, that example from the first week of class where human beings are so good at solving problems that we have difficulty articulating how we solve them. We don't think about this as a phone object in terms of all the details that are inside of it. We just kind of know what this thing does, and if we need to make a phone call or check our email on the go or check a Slack message, whatever it is, this is the tool we pull out. And we tap a couple buttons, we do it. We don't think very much about all the complexity that goes into this thing. We figured we spent our $1,000 on the piece of equipment, we've done enough, right? So we want to start creating our own object. So I know, conceptualize an object. So an object is a container that holds a bunch of logic, and I'll put in little parentheses, wires here, where all of the detail is hidden from the end user, and only the public interfaces are exposed to the end user. So, like I have a couple buttons here. So there's a power button over here. I have some volume buttons, and I have the special button for the Samsung personal assistant that nobody wants to use. Whatever. So you have those buttons, right? Those are the public interfaces that are spit out. And then you have a whole bunch of, fake public interfaces that are, given to you through the touch screen and that kind of stuff. All right, but that's the generic version of an object. So, in the history of programming type of perspective, a lot of times, we look at an object-oriented language as being an evolution of these programming languages. We've gone from procedural languages to object-oriented languages. And in our minds, we want to think that there's so much different there. It's Tupperware. We've given ourselves one little extra packing box and said, throw your details in there and shut the lid so we don't have to see the mess. That's the difference. All right, so the difference is actually very small in the big scheme of things, but it changes the way we do solve problems with it. It allows us to solve problems much closer to the way we would solve problems in real life. Okay, questions about that at the high level? All right, so classes, introduction, blah, blah, blah. I'm going to have you guys go through this. I just need to look at the syntax real quick. It's like def something with some selfs in there or whatever. Here, class example. That should show me enough. Yep, that'll work. All right. So, I think I've put all this stuff on Slack, right? Mm-hmm. All right, so I'm going to dump all of this at this point. Actually, just real quick. Random.randint. Okay. So we're going to create, we're going to think from like the nerdy Dungeons and Dragons days, where you play these tabletop role-playing games. And who cares if you've ever played one of these? Everybody in here has rolled a die at some point, right? Mm-hmm. You play Yahtzee or something like that. You roll a 6-sided die or a 20-sided die or a 20-sided or a 10-sided die, whatever it is. So we want to create a dice object. Okay? So we're going to create a dice object. Now, when we build a dice object, let's go back in here. We're going to say this is the name of the class. So I'm sorry, I already screwed you up here. This is the name of the class. We're creating a class called dice. And then inside of here, we're going to have a constructor. Init. Let me make sure I'm giving everything there. Yep. All right. And this guy is going to take in something called self and something called size as a parameter. I'm going to come back to this self thing in a little bit. For right now, let's just operate off of the reality that every single thing that looks like a function inside of a class always starts off with this self comma at the beginning of it. All right. This is how Python has implemented object-oriented programming into their language. All right. It was kind of like an add-on piece. Python started off as a scripting language. All right. So this guy is called a constructor. So let's go back here and let's add this to our... All right, so just like in real life, if I want a house object, right, so I'm going to have a house, and inside the house there's a whole bunch of details and stuff like that, and only some of them, only the public interfaces are actually exposed to me, so we can certainly think of a house as being an object, right? If I want a house object, I hire a contractor or a constructor to build it for me, all right? Somebody goes out there, I provide him with the resources that he might need. So if it's a buddy who's building the house for me for, quote, free, I would have to provide him with like the lumber and wires and all that stuff. If it's a general contractor who builds houses for a living, you give him money. Okay, here is $100,000, go. All right, so with a constructor, you're going to provide that guy with any inputs that he's going to need to get the ball rolling on that object, to build that object. All right. So constructors in Python are always named __init __. All right. And then you're always going to have self comma. Again, don't worry about that right now. We'll explain it here in a few minutes. And then comma delimited list of, we'll call this param1, param2, ... param n, something like that. All right, so all the inputs that this guy is going to need. If the general contractor is building the house, the one input might be money. If it's the buddy who's building the house, the inputs might be wood and then wire and then probably some money and then 500 other things, whatever it is. All the things that they're going to need to do their job. All right, so we're going to loosely define a constructor as the function, I'm going to say function-like entity. In Python, it actually does look identical to functions other than having to be called __init __. Okay, that is a requirement, and you'll see why here in a few minutes. All right, it expects it to be named exactly that. All right, so function-like entity that automatically gets called when a new object is what's called instantiated, which is a fancy way of saying created. Okay, instantiate, I think I got that spelled right. All right, because the idea is that if you have a single blueprint, all right, so if we go back to, let's just underneath object here, let's create something here called a class. All right, we saw that here in Python. Python uses the class keyword. Most object-oriented languages use the class keyword for defining objects. So when we think about class, we could almost, if we want to connect this to real life, we might say this is a synonym. Whatever, for blueprint. All right, so in real life, we kind of think of, the general contractor has this blueprint for a house that has all the details in it on how to build a house, and then he's going to use that blueprint to actually build a house. And a lot of times they'll build that same house 50 times. That make sense? Using the single blueprint. So a class is a blueprint that's used for, so we'll say this is a blueprint that is used to create multiple copies, instances of our object. Make sense? The class exists once, we use it along with the constructor to build 0 or more copies of that. in real life, there's a possibility that a contractor has a blueprint for a house and never actually builds one. You know, wasted time, but still a thing. Okay? So that's what a class is. Class is our structured way of defining a blueprint for an object. We then use the constructor of a class to actually build those objects from that blueprint. Make sense? Seeing how this kind of matches up to real life, we're just using a couple of funky sounding words that maybe make things a little bit more difficult than they have to be. All right. So, if I'm manufacturing a dice, okay, or a die, I'm calling it dice because it's easier to say. All right, so if I'm manufacturing a dice, you know, you have a 6-sided dice, you have a 3-sided dice, you have a 4-sided dice, you have a 10-sided dice, a 12-sided, you could have a 7-sided. I don't know if I've seen them before, but you could have any sided dice probably greater than or equal to 3.
Yeah.
Yeah, I don't know if you could. A 2-sided dice is a coin.
Yeah.
Right? Which I guess technically could be a dice, right? Yeah. But I mean, you don't really roll that. But I mean, I guess you'd have to kind of bounce it.
You can flick it.
Yeah, you flick it. But you know, when you think about a dice, you kind of think about rolling it. It kind of tumbles until it lands on a side. You couldn't do that with a coin. So we'll say at least 3 sides. Yeah, you'd have to chuck it at the ground.
Yeah, but then there's a bottom of it.
3-sided die, I think it does it. No, that's 4-sided because the bottom is the 4th side. A 3-sided die, I've seen them. I think it's almost like a cylinder with little edges on it. I think I've seen a 3-sided die. It's possible I haven't.
Oh, it's like the one where
I might be lying.
It's like
I've
seen them once at like RockCon in Illinois. I was gonna get it,
Yeah.
but it's like a cylinder.
It's like a pyramid, but it's like the numbers angle up. So there's 3 sides.
So you can have a
Like here, I'll pull a picture.
It's like a
Yeah.
like that.
Okay.
Well, that's very weird.
Yeah, that is kind of weird.
So we go 3 sides.
Yeah. Yeah, whatever it is. In our world, we could have a 1-sided die if we really wanted one. All right, because we don't have to worry about the manufacturing process because it's all digital. All right. See, I used to be the really cool kid at these because I was one of the dungeon masters at the tabletop gaming conferences.
Okay.
Yeah, so people would come over just because I had special dice.
Oh.
I had dice that were made out of asteroid.
Really?
Yeah,
That sounds cool.
it was awesome, and no other human being outside of there would care.
Well, were they like heavier? Maybe?
Super heavy.
Really?
Yeah, so they were little tiny dice, and they felt like, like it was probably the size of like maybe 2 peas put together was like the 20-sided die, and
Really?
it weighed as much as like a golf ball. Yeah,
That's awesome.
it was awesome. At least I thought it was awesome. Plus, they were magnetic.
Oh
Really?
man, that's
Yeah.
better.
I walked around. I had like a plate they stuck to. You show up, you could kind of throw it down.
Nice.
And you think you're cool, and like the 6 people standing around you that are dressed in chainmail also think it's cool. But then the second you go to the lobby of the hotel, you're no longer as cool as you thought you were.
Is he carrying on the other
All right, so this is the name of our class, dice. We're going to need a constructor for our dice. So when we build a new dice, we're going to say this is how many sides that dice has. Okay? Now, this is where we use that self keyword. So I'm going to say self.sides. I can name it whatever I want. Just variables typically should be named something that's meaningful. Is equal to the sides that was passed in. Now, let's talk about self for a minute. All right, so self, in other languages, some languages call it self. Other languages, you may have seen this as a keyword called this. If you were at the hackathon and you were working with Android Studio or Unity, you might have seen the keyword this. Also in Visual Basic, it's called me. There might be some other ones. These are all synonym type terms for it, but in Python it's called self. And this variable, so this is a variable that allows an object to refer to itself from within itself. Okay? So if we think about this from a person's perspective, in the world, I'm an instantiated object, right? I'm already an instantiated human. God used the blueprint, so we'll Christian worldview this. So God used the blueprint to create me, okay? And now I'm this human that's walking around, and I have this external name. The variable associated with me is called Mike, right? Now, internally, it would be weird to talk to yourself as a third person, like, well, Mike wants to go over here, Mike wants to go over there. It's kind of weird. You know, you think of it as yourself. That is mine. This is mine, not this is Mike's. That make sense? Mm-hmm. You know what I mean when I say Mike's, but it sounds weird. Now, when we talk about objects, if I'm an instance of the human object, internally, if I have functions that do things like I wave my hand and stuff like that, those functions need to be able to refer to me, but inside of me. They don't know about this variable named Mike. They refer to it as me or mine or I. I have these couple different things that inside your head, your self-talk, you can, how you refer to yourself inside your head. That makes sense? That's what self is, or that is what this is in languages like Java and C#. That is what me is in Visual Basic, which is kind of a stupid language, but me kind of makes some sense, right? Yeah. But in any case, most modern languages that you're going to run into, it's either going to be this or self. That's going to be your two go-to moves. Okay, Python itself. So that's what we'll be working with for a while. All right, does that make sense? The purpose of this variable? Mm-hmm. All right, and that guy's provided for us. So part of this, how Python has implemented this idea of a class says that all classes get this magical variable, called self. That is how they can refer to the stuff that they have from within themselves. All right. So if I were to create a new dice object, so maybe you're my constructor for dice. Okay. So you got your little dice making workshop, right? You're another one of those cool things. You got, you're right next to the Apple store in the mall. You can go to the Apple store, or you can go to the dice maker's workshop. So I walk in, and I'm going to say, and you're altruistic, so you don't even require money. Okay. All I have to do is tell you how many sides of a die I want. Okay, I walk in, I say 4. You start your whittling or whatever. You're hammering away. Maybe if you're chiseling it, probably. Because it's asteroid, obviously. So okay, so you do your job. I just need to provide you with the number of sides that I want you to create, and then internally you're going to build me this magical object that has a number of sides. So from that particular instance of dice's perspective, the number of sides that dice has, so if I'm the dice, the number of sides that I have, self.sides, is equal to the number of sides that the customer walked in and suggested you make the dice of that size, right? Mm-hmm. So these guys don't have to match in name. It just makes sense for them to match in name, right? I mean, you could always change this and say maybe this is num sides. The client asks for a dice with some number of sides, and then the dice is created with sides equal to num sides. That make sense? So, pick your poison. Most object-oriented programmers would name them the same. You pick this variable name for a reason. It should be the same variable name out here because you're talking about the sides of this object. Make sense? Mm-hmm. But I'm going to throw another little fact out here. Call this a variable truth. All variables resolved to their most local definition. And when I say resolve, I'm talking about boil down. When I say boil down, I say ultimately find their value associated with their most local definition. Okay? So when I say sides here, its most local definition is going to be the value sides that was passed in here. Now, in this particular case with dice, if we were dealing with a different kind of language, like C++ or C# or Objective-C, Swift, any strongly typed language, inside of our class, we would have previously said, we're going to have an int sides, and then we're actually going to set that value sides equal to the number of sides that was passed in here. So with that in mind, sides here refers to this guy. Self.sides, I'm giving it kind of the full path of where that variable lives. So rather than letting sides resolve to its most local definition, I'm saying, look, I'm talking about the sides associated with this particular instance of this object, which refers to this version of sides up here. Now, in Python, we don't get to see this hidden variable because Python is a loosely typed language. So we can just create variables on the fly. All right, so we don't see that, but right here we're saying, I want to have a variable associated with this particular instance, self, called sides, and I want it to be equal to the number of sides you passed in. Go ahead.
What determines the type?
Type inference engine associated with Python, just like all the functions we've written up to this point. We write a function, we maybe have the variable name named LST, expecting somebody to pass it a list, but if you want to pass it the number 7, you could. It's kind of a weak, in my view, it's a weakness of loosely typed languages. So I think part of loosely typed languages, one of the reasons why they're so prevalent is I think a lot of, one of the early ideas was that they were easier to learn. I don't buy into that. I think programming is the skill set at the heart of all that. I don't think one language is substantially easier to learn than another. In fact, in some ways, I think that loosely typed languages sometimes act funny. I think strongly typed languages are more predictable under certain circumstances. Now, outside of that, and this is more of the truth of a loosely typed language, because they don't need to focus on speed, loosely typed languages are often interpreted languages. Building an interpreter for a programming language is far, far, far easier than building a compiler for a language. So that's why we have a zillion different interpreted languages out there. You can go do a Google search for list of programming languages, and you'll find 1,000. All right, maybe we'll find 50 of them that are very prevalent. Okay, and a handful of those are strongly typed languages. Java, C++, C#, Swift, Objective-C, Pascal, which, that's an older type thing, COBOL, okay? But a very small subset of them are going to be strongly typed languages, and those are all the performance languages, where most of the languages will be loosely typed languages. And everybody and their brother can create a loosely typed language. We have popular ones, PHP, Ruby, Python, Go is one of Google's languages. Kind of keep going down the list. JavaScript, although JavaScript's loosely typed. But in any case, that's kind of the scoop. They're easier to create, therefore we have more of them out there, and they can then be built kind of special purpose for certain tasks, because they're effectively an abstraction for a problem. A language like Python is a general purpose programming language. We can use it to solve all kinds of problems. That's why we're teaching it in here. Okay? But you certainly could create a little scripting language that only handles bank transactions. has 5 or 6 functions built into it that their entire goal in life is to solve the problem of transactions that might occur inside of a bank. So you can get a job and not be a programmer, right? And with an afternoon of training, you would know that when something happens, you call one of these 6 functions. So you need to learn 3 lines of code, something like that. That makes sense? Then you don't need the big programming skill set. You just need to be able to cut and paste and change a word here and there. All right? But in any case, with objects here, we're going to say self.size is equal to size. So that's this size is this size. Self.size is the invisible guy up here that's associated with this particular instance of this dice object. Make sense? Okay. Self is going to be one of those things that's in your top 5 most important things available to you in object-oriented languages. It's also going to be one of those things that is going to take you a little time to get used to, but I promise you it'll be easier than recursion. Not as easy as merge sort.
Yeah.
Okay.
I see.
I've had multiple individual students come up and say they've actually had nightmares associated with merge sort, which brings joy to my heart. But I woke up in cold sweats. I was stuck in an infinite recursive loop.
That would be horrible.
I was just twitching. All right, so that's going to be our constructor for this guy. Now, after I walk into his shop and he hands me the nice shiny new die, okay? So here, let's go down here and let's create one of these guys. Pretty sure I remember the syntax anyways, but I might as well get it right the first time. Whatever. Somebody who's worked in Python a lot can tell me if I got this wrong. So I'm going to say a dice is equal to, actually let's call this, we'll call this a D4, is equal to dice, and I'll pass this guy a 4. Okay? So I'm going to call upon the constructor for dice, passing it a 4 for size. Notice that I'm not passing in anything for self. That's that's being generated magically, auto-magically behind the scenes. Okay? So I'm passing in 4, and that's going to come in for size. And I'm going to name my variable D4, and this variable is going to be the value associated with this variable. So just like if I said, LOL is equal to 7. Okay, in that case, I have a variable named LOL, and I'm setting it equal to the value 7. In this case, I have a variable named D4, and I'm setting it equal to the value that is returned by calling my constructor on the number 4. That makes sense? So I'm going to store in D4 this object. Okay? So I'm going to pass 4 in there, and then that guy is going to internally, so this syntax right here where I say the name of the class, when I create a new object, a new instance of that class, it knows to automatically call this function called __init __. That function needs to be named very specifically that in order for this little syntax here, this pretty syntax to work. Make sense? All right. So now right after this, if I were to say print D4, what do we think would print out? Is this in down? Oh, good. We already have it up. This gives me the memory address, or kind of a wrapper for the memory address of that object. Okay? Because you're not that friendly. So what you did is I walked into your shop. I said, I need you to build me a 4-sided die. I said, no problem. So you went away whittling, and then you hid it somewhere. Okay, and you came back and handed me a little piece of paper. So this is where you can find your thing that's the size of a marble. Okay? I've hidden it somewhere in the mall. All right, so this is our memory in our computer, right? Okay, so he built it, stuck the actual object up in memory, handed me a piece of paper where I can go and find it. Mm-hmm. All right, make sense? All right, so the value associated with the returned value of the constructor is going to be a pointer to that guy in memory. Okay, pointers are variables built for holding memory addresses. We've discussed that before, right? We talked about pointers at the high level?
Yeah.
Okay. All right, so when we print that guy out, we get the crazy memory address associated with him. If I say d4.sides, I will get the number of sides associated with that memory address. And in this case, since I built the guy with 4 sides, I'm hoping he's competent. Therefore, he has whittled me a dice that has that number of sides. So d4.sides should give me a 4, the number of sides associated with that object. Okay? Now, when we think about dice objects, okay, when I go and buy this this dice object from him, well, when he hands me my free dice object after I've requested for a 4-sided one, what am I going to do with that dice object? What are things that we do with a dice? Roll it. Okay? Now, if I have a 4-sided die and I roll it, what do I expect to get as an answer?
A number 1 through 4.
A number between 1 and 4. A roughly random number between 1 and 4. I mean, I go to this guy because, he weights it a little bit and gives me some results that are a little bit more predictable. Okay? But generally speaking, we should get a value between 1 and 4 evenly, right? About the same chances of any one of those. So we're going to have a function in here, def roll. All functions start off with that thing called self. All right. Now this guy doesn't need any other information. I'm going to ask this dice to roll itself. I don't need to provide it any other information. It knows how many sides it has. All right. And we're going to go ahead and we're going to generate a random number between 1 and 4. How do I do that?
Use the.
So we're going to return. I'm just going to pound on the keys. That's almost going to be just as accurate as. We're going to return random.randint. And this guy takes in a range, correct?
Mm-hmm.
Now remind me, if I give it the range of 1 to 4, I think that includes the 4, does it not? We'll be able to test it pretty quickly. A lot of random number generators in other languages, this would give me a number between 1 and 4 not inclusive.
So 1 and 3.
It would give me 1 to 3. I'm pretty sure I remember we've tested this. I think this gives me 1 to 4. Okay? So that's what this roll function does. It generates a number between 1 and 4 and returns it. So what I'll go ahead and do is I'll give myself a little loop here. I'll say for I in range of 0 to 10. So we'll do this 10 times. And we're going to go ahead and print d4.roll. So I have a variable called d4. I'm going to ask him to go ahead and call his roll ability, just like I have this phone object and I can push a button on it to make a phone call. Okay? I'm going to call I'm holding up a die. I'm going to say, I want you to roll. Now, usually we have to import our little force on it, but not this guy's. That's not this guy's dice. Okay? We just kind of sit on the table, we boss it around. Roll! And it goes, rolls. Okay? And it's going to shoot back to me some number between 1 and 4. I'm pretty sure it's 1 and 4. Okay? Or 1 and 3 is accurate. Because this is one of those situations where I don't use Python enough to be 100% sure, right? So I'm going to go ahead and roll it 10 times, and I feel pretty confident that we're going to get a 4 somewhere in those 10 times. Right? If not, we'll just up it. Right? We'll roll it more than that. Each time through, I'm going to print out the result of calling the roll function with this particular instance of D4. So I should get a bunch of numbers between 1 and 4, hopefully. Row. Randint is a lowercase I?
Yes, lowercase I. C# has a lot of capital stuff.
Yeah. All right. Yep, I got some 4s. So here's my random rolls. Well, I told you he weights it a little bit. He puts a little, I mean, I don't know, what do you use, like Gorilla Glue or something? I mean, he's got to look the same as the rest of it. He puts something there to give me a couple extra 4s. You know, because I play on it. Is there some game that 4s are good? Yeah, it's the made-up game I play with my friends.
With your 4-sided die.
Yeah, with my 4-sided.
Yeah, but I'll do 4-sided die.
Yeah, the best use for 4-sided dice if you live in an apartment with other nerds is to scatter them about the house so that when it's 3 a.m. and they're walking around barefoot,
That's worse than like.
there is nothing worse than stepping on a 4-sided die with all your weight.
Why not Lego?
Oh, Legos have nothing on 4-sided dice. 4-sided dice, you might as well just have a nail sticking up. Except nails go in smooth. 4-sided die spreads. Yeah, it's what we should be using in wars. Is what it comes down to. Okay. So this is the function to roll that guy. Now, at the same time, let's look at the generic aspect of this. I can go ahead and give myself a D20, and this will be a new dice. So I go back into your shop, and I ask for a 20-sided die this time. So I pass the constructor a different number of sides. He will then go and create for me a new dice. I'm going to store this guy in a variable called D20, and instead of rolling my D4, I'll go ahead and roll my D20. So now I should get 10 numbers between 1 and 20. Go ahead.
Don't you still have the roll self 1 to 4 for a random number?
Oh, I do. I do. It's a good catch. I did this on purpose, obviously. Okay. So this is going to give me a number between, again, 1 and 4, even though this guy says 20. So we'll go ahead and run this. And then we go, why is it doing this? I want this roll function to be generic. I wanted to roll my dice a number of times related to the number of sides that this particular dice has in it. How can I pull that off?
Can you change the 4 to self-size?
Absolutely we could. Self.sides. So I wanted to roll between 1 and the number of sides this particular dice has. That make sense? Now this function is completely generic, and it's related specifically to the number of sides that this particular dice was built with. So now I'll get my values between 1 and 20. Make sense? Okay, so questions on that? All right, so what we want to do, this is going to be outside of the dice class. We want to write a function that rolls a, let's do a D20 10,000 times. So a D20 is a 20-sided die. Okay, it's going to roll that thing 10,000 separate times. What we want to do is we want to store in a list containing 20 elements the number of times each roll occurs.
Oh.
All right, so as an example here, an 11 occurred twice in this, a 5 occurred twice, a 17 occurred once, a 19 occurred once, so on and so forth. But you're going to make 10,000 rolls. And after each roll, you're going to ask the question, what did I roll? And you're going to have to keep track of how many rolls that particular thing was. And in the end, then print the counts. So the hope is that with 10,000 rolls, you should have roughly an equal number of values between 1 and 20. Roughly, right? that make sense?
Mhm.
And if I said this should be 1,000,000 rolls, it shouldn't make any difference. 10,000, 1,000,000, it's probably going to be the number of times you go through your loop. All right. The hint here would be I would probably create a loop. I'm sorry, I would create a list. And in that list, I would store at bucket 0 the number of 1s I get. At bucket 1, the number of 2s I get. So on and so forth. If you don't want to have to do the offset math, you could just store at bucket 0 a -1. And then at bucket 1, the number of 1s. At bucket 2, the number of 2s. At bucket 3, the number of 3s, so on and so forth. That make sense? All right, questions about what I'm asking you to do here? All right, so I'll put this code up on Slack as kind of your starting point. So I'm already giving you the dice object. Now I'm asking you to use this. Okay, does it sound a little easier to merge sort?
Oh yeah.
Yeah.
Okay, so no excuses if you don't get this one right.
Yes.
All right, I will see everybody on Wednesday.
So which